the topic before us is the topic called vectors. So when we mention vectors, certain ideas come to mind. Number one, for those of us who are not science students, the first topic, the first word that comes to our mind will be that of science. And what branch of science? It will be physics. And while still dealing with physics, we'll be dealing with something they call quantity. Not just quantities alone, but also be dealing with an aspect called physical quantities. So the trend is from science to physics to quantities and then to physical quantities. So what then is a vector? A vector essentially is a type of physical quantity. So to stretch this discussion, we can describe vectors we can describe physical quantities in terms of whether they are vector quantities or they are what? Scalar. So if you want to have like an opposite to vector or another type that will describe a physical quantity, we consider what? Scalar. So if a quantity can either be vector or scalar. There is another one that pertains to whether it is fundamental or derived, but that does not serve the objective of this class. So we restrict our discussion to whether it is a vector or it is what is scalar. Now, what then is a vector? When we classify physical quantities under vector and scalar, two ideas come to mind. We look at the matter of direction. Of course, we cannot be talking about direction if we are not considering the magnitude. So, a vector is a quantity or a physical quantity with what? Magnitude and direction. That's what a vector is. A vector is first of all what? A physical quantity, which means it's something tangible, something you can feel, that has what? Magnitude and direction. So that will be what you will call a vector. One of the interesting aspects of vector is that vector comes under a branch of math we call geometry. It comes under a branch of math we call what? Geometry. If you were taking this in further mathematics, you'll be treating that under an aspect we call vectors and mechanics. For those who are offering further maths, I know since we have B students here, it's important for us to stretch to see where this will also be applicable. So, I think it's also important that we take some examples of vectors. So, I'm going to take just two examples and show you how they may seem the same, but they're actually not. So I'm going to start by saying, writing two things on the board. We have speed and we have velocity. We have, what's the other one now? There's one I'm thinking of. We have speed, we have velocity, we have, remember what I want to talk about, distance and displacement. Now, speed and velocity are related. How fast a car can go, the velocity of a car, they are all related. This car is firing very well. Speed will mean what distance is it covering per time. If it covers so much distance per time, we say that this car has a very high speed or velocity. But if it's covering very little distance per time, we say that this car has very low velocity. So we say it's not sharp. Now, what differentiates speed from velocity is the concept of what? Direction. When we talk about speed, we are not interested in direction. When we talk about velocity, we are interested in what? Direction. So I can say, what's the speed? Speed means that I'm going to use distance. I can go like this and like this, and I just take the distance I've covered and check the time and what happens? I'll get my speed. But that is not true for velocity. In velocity, I am interested in the particular displacement, particular movement. So if I'm moving like this, the time it takes me to move like this, working upon distance, is what is called what? Velocity. So by way of example, these quantities are what? Velocities. And I mean, these quantities are vectors, but these ones are what? Scalar. They look the same, but they are not the same.